Hello everyone. In this video we are going to discuss about differential calculus, which will be helpful for us in understanding the different concepts of electrodynamics. So let's start. So let me put the heading over here. Differential calculus. Differential calculus. And the very first topic that we are going to understand in differential calculus is ordinary derivative. What's the topic? It's ordinary derivative. I hope that all of you have studied calculus beforehand, because electrodynamics is generally taught after calculus, but still I would be telling you a bit of facts about ordinary derivatives. So to write ordinary derivative, suppose there is a function fx. Suppose there is a function f, and I have to find the derivative of f with respect to x. So we write df upon dx. Now, what does this df upon dx gives? It gives, if there is a graph of f with respect to x, something like this, then this df upon dx would give us the slope. What would this df upon dx give us? It would give us the slope of the graph. I hope that it's clear. Now, the next thing that we move on to is partial derivative. Partial derivative. Now, what do we mean by partial derivative? Ordinary derivative means taking the complete derivative of function f with respect to x. But in partial derivative, we don't take the complete derivative. Rather, we take derivative only of some parts of, or only with respect to some particular variables. Let me give you an example. Let this be function f, which is equal to x square plus xy plus y cube. Okay. Now, if somebody asks you to find the partial derivative of this function f with respect to x, so what would you do? You would simply write del f upon del x. Now, one thing that you must keep in your mind, that this is a different sign in comparison to this. Here we write simply d, but here we do this as curved sign. Okay, I hope that it's clear. Now, when you have to find this, you will simply write the function f over here, that is x square plus xy plus y cube and dx. I hope that it's clear to you. Now, when someone asks you to find the partial derivative with respect to any function, then you have to differentiate the given function only with respect to this particular function, or with respect to this particular variable. That is, we will differentiate this completely with x by taking x as a variable and all the other things as constants. I hope that it's clear. Now let me do it. What would be the derivative of x square? It would be 2x. What would be the derivative of xy? It would be y. Why it would be y? Because as we all know that derivative of xy would be y. The reason is that here y is constant and it is treated as any random scalar, and x is a variable. So when we take the derivative of yx or xy with respect to x, then we get y. Now y cube would be 0, since this complete thing is a constant. Now the next topic that we move on to is gradient. What is the next topic that we move on to? The topic is gradient. Let me write the heading over here, gradient. What does gradient mean? Firstly, when we will find gradient of different functions, the gradient simply means, or the gradient is a vector that points in the direction of maximum increase of the function. Again, let me repeat it. Suppose there is a function t. Okay. So what would the gradient represent if we take the gradient of t? So when we take the gradient of t, then it represents, this is the way we find gradient of t, that is del t. Now what is this del operator? We will learn about it later on. So the gradient of t points in the direction, it points in the direction of maximum increase of function t, in the direction of maximum increase of function t. Now let us see how do we find the gradient of any function. So let's turn to the next page and let's see that how do we find the gradient of any function. As on the last page we had seen that t is a function, and when we find the gradient of t, then what do we get? We get the direction in which maximum increase of function t will happen. Okay, now how to find the gradient? So we find the gradient by this method. Here it represents gradient of t. What would be the gradient of t? Partial derivative of t with respect to x and x cap. That I had already told you that I will be using x cap and I cap alternatively in the starting lectures. Now del t upon del y cap plus del t upon del z cap. So when we do the partial derivative and take this x cap, when we do the partial derivative of t with y and take this y cap, this complete vector, this vector or this gradient of function t would give us the direction in which maximum increase of function t will happen. I hope that you understand what does gradient mean. Now after understanding the gradient, I will give you a problem to solve. Please try it. So here the problem says that find the gradient of function r equal to x square plus y square plus z square. Pause the video, think for a while and solve this problem. Now let's solve this problem. So here we write the solution of this problem. Now as we know that gradient of r would be dr upon dx x cap plus dr upon dy y cap plus dr upon dz z cap. Now we firstly take dr upon dx, that is partial derivative of r with respect to x. Then we would simply get 1 by 2x upon under root x square plus y square plus z square. In the similar way we would get in the case of dr upon dy and dr upon dz. 1 by 2y under root x square plus y square plus z square. Here 1 by 2z under root x square plus y square plus z square. Now this 2 would be gone. So what we would get? We would get x plus y plus z upon under root x square plus y square plus z square. And if you don't get how I wrote this, then let me also make it easy for you. When we take the partial derivative of this particular function, that is under root x square plus y square plus z square with respect to x, then what do we do here is that firstly we take the derivative with respect to under root x square plus y square, x square plus y square plus z square. So what does it come? It comes 1 by 2 under root x square plus y square plus z square. Now secondly we take the differentiation of x square plus y square plus z square with respect to x. From that we get 2x. I hope that it's clear that how we arrived on this result. This is the way in which we do partial derivative and we find gradient. I'm sorry for this. This will not be done in this way. I cap, j cap, k cap, and this is not what we are going to do. I'm really sorry for that. I thought that it's a scalar. But this is the way that we are going to find the gradient, and this particular gradient is pointing in the direction where the maximum increase of function R will happen. I hope that gradient is clear, and also the use of gradient is clear to all of you. If you have any doubts, please put it in the comment section. I would be really happy to help. Thank you very much for watching the video.